So lesson 4 we're looking at is using probability models. We'll talk in a little bit about what a probability model is. If we look at this on page 373, Chess Club has 8 members. A new captain will be chosen by randomly selecting the name of one of the members. Leah and Luke both want to be a captain. Leah says the chance she will be chosen as captain is 1/2 because she is either chosen for captain or she is not. Luke says the chance he is chosen is 1/8. So for this problem, Luke actually is the one has the right idea about this thing because there's 8 people. He's 1 out of the 8 people. You know, it's kind of like if we had 8 cards numbered 1 through 8 and we said, what's the chance of us picking a 3? That's kind of what this is like, right? It's 1 out of the 8 things that's being chosen. You have a 1/8 chance of being chosen. You have a 7/8 chance of not being chosen on the flip side of that. So if we look at example 1, we're going to do this kind of in a different order than what the book's doing. First of all, let's talk about a sample space. I think it makes most sense talking about it in this order. So sample space is just a set of possible outcomes. Set of possible outcomes. So for example, if I'm flipping a coin, my sample space would be heads and tails. When you do a sample space, usually what we do to write a sample space, we put them in braces. If you look in the book, their braces are a little bit better than the ones I just drew. And they just have commas in between the different options. Okay? So flipping a coin, we do the braces on the outside, and then we put heads, comma, tails. That's our sample space. Okay? It's just what could possibly happen. If we look at right above that, the book talks about the probability model. So probability model consists of the sample space and their probabilities, basically. So for example, if the book said find the probability model for flipping a coin, we just did our sample space would be heads and tails, and then we would also do the probabilities. So we would say, probability of heads is 1/2 or 50%. Probability of tails is 1/2 or 50%. Okay? So those two components together make up the probability model if they ask us to do that. One thing about the sample space, if we look at this on this problem, Mr. Campbell has a jar on his desk, contains 10 marbles. At the end of class, each student draws a marble from the jar without looking, notes its color, then puts it back in the jar. If a student draws a red marble, the student gets a pass on that day's homework. How can students determine the probability of drawing the red marble? So this is what they're kind of talking about over here. So the sample space, those are the marbles. So if you look at the sample space, they're abbreviating, but they do explain underneath here what their abbreviations represent. Okay, so we have 1 red, 3 green, and 6 purple marbles. Notice in the sample space, they have an R, they have 3 G's, and they have 6 P's. You might look at that and you might just say, well, the possibilities, it's only either going to be R, G, or P. That's true. It is only going to be one of those 3. The nice thing about putting all of these separately, that will tell you how many total options you have, which will help you figure out your probabilities easier. Does that make sense? In other words, if I would only put R, G, P, I might think I have a 1/3 chance of getting any one of those. I actually don't have a 1/3 chance of getting any of those. it's, based off of the 10 marbles that I have. Okay, so that is the sample space listed there. Again, if we listed our sample space here along with the probabilities here, those two things together would make up our probability model. So probability of getting the red marble would be 1/10 or 10% chance. So we look at the try it. Mr. Campbell decides that too many students are getting a pass on homework. He adds 10 yellow marbles to the jar. Tell whether each part of the probability model does or does not change. So if we think about this, the sample space does change. Okay, sample space was the different options we had. We had listed out all the red and green marbles there because now we're going to have also 10 Y's included in that, right? 10 yellow marbles. And then each event within the sample space does not change. This one's a little vague maybe. We still had our other stuff. We still had red, green, and purple that are not changing here. We're just adding the yellow into the mix. And then the probability of each event does change because now we have more marbles, right? And so the new probability of drawing a red marble is 1/20th because now we only have one red marble out of a total of 20 marbles. We had 10, now we have 20, so our chance of getting that red marble just got cut in half. Now we're at 5% chance instead of 10% chance. So look at example 2. Miss Stillman has a marble jar for the same purpose, but students do not know the number of marbles or their colors. None of them are red. No, just kidding. Each of the 30 students draws a marble, notes its color, then puts it back in the jar. Based on the results drawn in the table, what can the students conclude about the probability of drawing a red marble? So this time we don't know what the marbles are. We just know what happened when they drew the marbles. So when they drew the marbles, 4 people ended up getting a red marble, 11 got a blue marble, 15 got a green marble. So if we look at this then, we can look at our probabilities. Now, this time we don't know for sure how many there are of each. So since we don't know how many of each, they're just saying our sample space is red, blue, green. We don't know the amounts of each to put there. So that's why we're not doing that. But if you'll notice then, we did have, like it told you in the problem, there were 30 students that were drawing the marbles here. And then if we look at the table, 4 of those out of the 30 drew a red marble. So that's how they got the 4/30ths. Or we could reduce that. Always reduce if you can. 2 out of 15. Blue marble is 11 out of 30. Green is 15 out of 30, or a half. So based off of that then for the red marble, we could just figure out that 4/30ths or 2/15ths if you divide that out, and you'll get looks like 0.1 and then a bunch of 3's. Okay, so if we move our decimal 2 spots to the right, that would be like a 13.3 repeating percent, or 13 1/3% chance. Okay, so was that higher or lower chance than what we had in the other class? Higher, right. The other class was 10% to start with, and then we changed it to 5% because we were getting too many free passes. So look at example 3. Miss Stillman tells her students the jar contains 100 marbles. Based on the table, we have a new table now we'll be looking at. Marble colors after 60 draws about how many marbles of each color are in the jar. So we have 100 marbles with 60 draws. This is what happened. How many reds, blues, oranges, and greens. Okay, so based off of that, we got a couple options. One option, we could do a proportion. We could say red happened, for example, red happened 7 out of 60 times, and then how many out of 100 is that? Okay, in this case, they're wanting a number out of 100. Well, I know a number out of 100 is a percent. So the other option, rather than doing a proportion, would be we could just divide 7 by 60, find what our percent is, and then just round that off. So you can see that's what they did for these problems. With the red then, working that out, it's about 11.6 repeating. We're not going to have part of a marble, so we'll go ahead and round that off to 12 marbles, 12 red marbles. For the blue, there were 20 out of 60. Again, if you want to divide that out, or you can do a proportion, should come out to be about 33 blue marbles. Orange marbles was 1 out of 60, so that would be closest to 2 orange marbles and out of 100, and the green, 32 out of 60, should be about 53 green marbles. And again, the assumption here with these numbers, the assumption is that the experiment that we did is exactly mirroring, or very almost exactly mirroring what the actual number of marbles is that we have. Okay, that our experiment and our theoretical are pretty much identical, which may not exactly be the case. We look at the try it then. To reduce the number of homework passes, which color of marble should Miss Stillman use as the pass on homework? Right now, if she's using red, that would be 12 red marbles. So to reduce this, the only with fewer marbles than the red would be the orange. So if she switched it to orange marbles, then that would should lessen the amount of people that get their passes on homework. So the key concept, just recapping again, when we talk about this probability model, again, if they ask for a probability model, you need to do two things. You need to give the sample space, which is the possible outcomes. So in this case, if we're rolling a number cube, 1 through 6, sample space is 1, 2, 3, 4, 5, 6. And then we'll give the probabilities of each. 1/6 is not a real great percent if you divide that out. So if you want to just leave those as fractions, that's fine. Just make sure if you have fraction answers that you reduce those if possible. So look at the do you know how. Number 4, they want us to develop a probability model for the spinner. So for the spinner, first of all, our sample space, we can list out the different possibilities here, which would be 1, 2, 3, 4, 5. Again, if one of the numbers showed up more than once, we'd probably want to list it more than once in our sample space, just so we know how many different possibilities we're looking at. And then we'll list out our probabilities. So the probability of getting a 1 would be 1/5, or if you wanted to say 20%. Probability of a 2 would be 1/5. Probability of a 3 is 1/5. Probability of a 4 is 1/5, and surprisingly, probability of a 5 also is 1/5. So all that information we need when they're asking for a probability model. You look at number 5. Mr. Henry has a basket full of fruit. He does not know how many pieces of fruit are in the basket or the types of fruit. Each of the 20 students in his class selects one piece of fruit from the basket without looking, notes its fruit type, then puts it back in the basket. Based on the results shown in the table, what can the students conclude about the probability of selecting an apple? And that statement is important, that they say they're putting it back in the basket. Then we know the next person has the same chances of getting each of these types of fruit. So out of the 20 times, this is what happened. We want to find probability of selecting an apple, so this is all we really care about in this table. So the apple was chosen 5 out of 20 times. 5/20ths, you could reduce that down to 1/4, or if you divided it out, that would be a 25% chance of getting an apple. So either of those answers would be fine. And then if we look at number 6, probability model based on experimental probability for randomly selecting a marble from a bag is listed there. About how many marbles of each color are in the bag if there are 60 total marbles. So for green, they're giving us a number out of 40. We want to figure out a number out of 60, so that sounds like a proportion. For this one then, if you tried to work this out, if you didn't have a calculator especially, or even if you did, sometimes if you can reduce the fractions, that'll make things a little bit easier for you. So for that, if you'd reduce those by 2, then that would end up being 27 green marbles. And then we'll just do the same thing for the other two here. For the blue was 14 out of 40, which we can reduce to 7/20ths. So 7/20ths, again, same pattern, multiplying by 3, would be 21 blue marbles. And then for the white is 8 out of 40. Now for the white, we actually do have a pattern here with the 8 and the 40. Remember, the pattern can be across or up and down. This would be dividing by 5, and so 60 divided by 5 would be 12 white marbles. So this gives you an idea of how to use probability models. The following slides will just show the answers to the problems on your workbook page if you have any further questions about this.